Okay, sir. A very happy Sunday morning to everyone. Technology is best when it brings people together, realizing its importance. Our RMK group of institutions is conducting a weekly generic talk series on the emerging technologies. On behalf of the management, principal, team, HODs, and the faculty members of RMK CET, I warmly welcome our distinguished speaker for today, Dr. R. Praveen, Technical Lead, Research and Development, ICU Medical Incorporated, Chennai, for the generic talk series on the art of machine learning, infusing fun with orange. Welcome, sir.
Thank you, ma'am.
Now, I request our Professor and Head Department of Computer Science and Engineering, Dr. P. Valarmadi ma'am, to give the welcome address. Please, ma'am.
Yeah. Is it audible?
Yes, ma'am.
Respected guest speaker of today's generic talk series, Dr. R. Praveen, Technical Lead, Research and Development, ICU Medical Incorporation, Chennai. Respected Principal, Sir Dr. K. Ramar. Respected coordinators of this program, Dr. N.R. Reginpal and Dr. N.P. Ponnuviji Madam. Dear students and faculty members from RMK Group of Institutions, happy morning to one and all present here. Uh, on behalf of our management and RMK College of Engineering and Technology and Department of Computer Science and Engineering, it's very immense pleasure to welcome our today's guest, Dr. R. Praveen, Technical Lead of Medical ICU Medical Incorporation, Chennai. Welcome, sir. I would like to welcome.
Good morning, sir.
Good morning, sir. I would like to welcome our respected Principal, Sir Dr. K. Ramar, for his continuous motivation and encouragement in all aspects. Welcome, sir. I am very happy to welcome the coordinators of this today's talk series, Dr. N.R. Reginpal and Dr. N.P. Ponnuji Madam, and student participants and faculty members from RMK Group of Institutions. Welcome you all. Today's topic is very interesting, am I right? So, building machine learning model using Orange. So, we are going to use Orange tool to develop a machine learning model. It's a very interesting topic. I request all the student participants and faculty participants kindly interact with our guest. Is a very good speaker in this machine learning model. Kindly interact with the at the end of the PPT. So we have the 5 minutes the question and answer session. So I request all the participants to whatever the clarifications and doubt you have, kindly interact with the speaker. Have a nice day. Thank you.
Thank you, ma'am. Now, I request our esteemed principal, Dr. K. Rama, to deliver the presidential address. Please, sir. Sir.
Sir is mute. I think so.
Yes, sir. Yes, ma'am.
Now.
Now, I request our esteemed.
line.
Okay, okay.
Madam, Panuji, madam.
Sir,
Hello.
Sir,
Yes,
am
madam.
I? Yes, sir. Yes, sir. Now I request our esteemed principal, Dr. K. Rama, to deliver the presidential address. Please, sir.
Very good morning to all of you. Respected Chief Custody Program and Resource Person, Dr. R. Praveen, Technical Lead, Research and Development, IC Medical in Chennai, the HOD of Computer Science, Dr. Valarvati, the Coordinator, Dr. Ponviji, and the participants from our group of institutions, both the faculty member and students. Very good morning to all of you. At the outset, I'd like to thank the organizers of the program for giving this opportunity to deliver the presentation address. My dear members, our management, especially our chairman, vice chairman, encouraging us to learn the new emerging field, both technology and language. Based on that, they are guiding us to conduct a generic talk every week. Both all three institutions are conducting and this type of program for students. My dear students, the field like machine learning, artificial intelligence, and the cyber security, etc., are the emerging field. And the languages like Python, Java, C or C++ are the languages are used in the IT company to solving any problem. Based on that, we are organizing this type of program for the benefit of faculty member and students. My kind request to all the participants to interact more with our chief guest, Dr. Praveen sir, to get more knowledge in the machine learning. So with this, once again, I thank and congratulate the department for giving me a chance and organizing this program for the benefit of our faculty member and students. Thank you all. Thank you very much.
Thank you, sir. It is my pleasure to introduce our honorable speaker for today, Dr. R. Praveen. Dr. R. Praveen finished his UG in Computer Science and Engineering from K.S. Rangasamy College of Technology, Tirchangood in the year 2015. He finished his PG in Computer Science and Engineering from Madras Institute of Technology campus, Anna University, Chennai in the year 2019. He finished his doctorate in Computer Science and Engineering from MIT campus, Anna University, Chennai. Dr. Praveen is a Brainbench Java certified programmer with expert level proficiency. He has strong technical skills in various web technologies and frameworks, and he has successfully handled and completed many projects. Dr. R. Praveen acts as a Board of Studies member for the Department of Computer Science and Engineering in the college where he pursued his UG. He has delivered numerous guest lectures in many reputed colleges across the country. He has presented many research papers in many international and national conferences. His reputed papers were also published in various international journals. I now invite our speaker, Dr. R. Praveen, to take over the session. Please, sir.
Thank you, ma'am. Thanks for the warm welcome.
Thank you, sir.
Um, I want to share my screen, but the screen sharing is disabled.
Okay, sir. Regin, sir.
Hope my screen is shared now.
Yes, sir.
Yeah. Again, I would like to place my thanks for inviting me the for this series, and in especially you have spent your holiday time, that to Sunday time, to share the knowledge and enrich your students. Uh, so I would like to place my congratulations as well as the thanks on behalf of all the students to the management of your college and the faculty members. So with that, I would like to join you with this series on the topic called machine learning with Orange tool. I would like to extend somewhat how the deep learning also uh, implemented in the Orange tool. So in this entire 1 hour, we would like to interact then and there, how we can use and what are the tricks and some things. So if students are there, you can if start interacted, so the session will be more interactive as well as beneficial. So if permits, allow the students to talk so that we can have the interactive sessions. Okay. To start with session, I would like to place few questions, like if any of the students are willing to answer, you guys can answer. First, my question is what is a data set? That is the base for machine learning, right? So anyone can say like what is the data set? Okay. If not, we can directly go to the session. I would like to introduce you a new tool for Orange. Probably some of you might already aware, or few of them are not aware. We can just see uh, what is the tool called Orange. Orange is a tool which is as your principals are insisted, whatever the machine learning or deep learning algorithm which we are developing, the preferable language that we are using currently is Python, right? So even if any user or any programmer don't want to write any code for their uh, what we can say, for basic fundamental machine learning and deep learning operations, pre-processing the data or doing some predictions or doing some classification and other stuff of existing algorithm, like we have a vast range of algorithms that supports for machine learning and deep learning, right? So for example, logistic regressions, KNN, decision tree, these are all the existing algorithms, right? We are frequently going to use. So we no need to spend our time to again take a code, run or build. So something. So we no need to do such, so right. So if any tool that can help us like without coding, just we can drag and drop some things and we can achieve these kind of existing algorithms to operate on a particular specific data set or uh, real data. So for that, the answer is yes. We are having a tool called Orange. It is absolutely zero coding tool. Means you no need to write any code. We can directly use the existing what we can say. It is kind of visual component based programming. We already have some languages that supports component based learning, right? For example, c#.net. In c# we can have the components for link for drop down and everything. We can just drag and we can design our forms, right, instead of writing a basic HTML code. So such and another one is we have Visual C++. So there and all we have component-based programming. Yeah, so those kind of it is Orange is a similar kind of tool where we have widgets. We can just drag and drop the widgets for its own purpose, and we can achieve our algorithm. For example, if you want to uh, read the data from the Excel file or file, how we can do? We have to write a code either in the Python or Java. We have to open the file and we have to read them. We have to pre-process and if we want to provide some reports like number of records read and number of records which is having the labels. Like what is mean by labeled data and unlabeled data. That and all you aware, I guess. So those kind of information we need to read the entire file and we have to build our report and we have to show, right? So for these kind of operations we no need to write any code. As I said, we can just drag and drop a specific component that supports for data import, file import, or even if in the same way, if we want to read an image, how we can read an image? We have to in the legacy way, I'm saying, as I am a Java developer, I would say like I have to read an image and I have to convert that to block and I have to store in database, and I have to, while retrieving, I have to again um, read the blog, and I have to reconstruct the image and so on, right? So these are all time consuming as well as the repetitive task. So instead we should have some image import options. By using the components, we can just drag and drop those components and we can able to achieve this task. And also, like, in the orange we have a huge variety of components available that is supported for machine learning, deep learning, or even AI related. And previously it was supporting for data mining, basic data mining operations. Now it's evolving and it is reaching to the area like it supports for data science. So until it's evolving, since one more advantage is this is an open source tool, so we can take the tool, we can change our code, and we can implement our own components and we can use it. So that also it supports. So this is the tool where it is getting popularity day by day. So so we can also use this tool and we can explore all the areas like in machine learning, deep learning, data science and all, and we can achieve our task in a matter of seconds. I would like to show you like how we can achieve all these things in upcoming slides. So I would like to introduce this tool. Like there are these are all the important jargons that we need to know. Like why we are started working on the Orange tool. The one is called as Canvas. I will Canvas is an area where we can just drag and drop the components and we can connect and we can operate. So meanwhile, I am going tool as well as the PPT then and there, so that you can able to follow up. So this is the tool uh, called Orange. So how we can get this Orange tool is like if you have Anaconda Navigator, in the Anaconda itself we have there are a number of tools supported by Anaconda, right? So one of the tool is called Orange that is available as part of Anaconda. Otherwise, we can install Orange as a standalone application. That too we can do. Or if you have a Python installed, then you can use the pip command and you can get the Orange tool and install in your machine. So I have used, like, I have installed in a standalone tool. You can just Google it and find the Orange tool for AI and ML. You can get this first link and you can able to install it. So once you have installed, this is the canvas area. Like for example, I will close and show you. Like this is the icon that will pop up once we have installed. Once you have opened the tool, you used to get this welcome page. So in this welcome page, if you see, it is having a clear documentation, like documentation support for each and every tool. Like if you don't know how this tool and how the each and every widgets, like as I said, the components, we don't know any components, how we can know, like, so for that they have provided clear documentation support for each and every components. Like as I said, if you want to input data to the Orange tool, there are several options. Like we can either uh, go by file import, or if you want to import data from the Excel, we have a CSV file import. Or as I said, machine learning, we used to operate over data sets, right? So import from the data set, we have an option called data sets. And even if you have some real databases. So for that we have a option to import those data directly from the database. For that we have SQL tables and for data tables. And even for example, if you have uh, paint data, for example, if you are even we have in academic we used to learn the k-mean clustering and other stuff by using the paint data, right? We can place points over the 2D plane, and we can say like how the clustering will happen. We used to take some cluster centroids and we can find the similarity between the points, and we can group and found the similarity of one cluster, and we can arrange them in a one cluster. And the points which are away from the one cluster center, that will be either classified as outlier or it will be grouped by some other clusters, right? So for that and all, we have uh, input from the 2D plane points, right? For that, we have an option called paint data, and we have a rank widget that Like for example, if we are working on data sets, in the data set we used to have n number of features. Like let's say we have thousands and 10,000s of uh, features for a single data set if it is of a real and complex domain. So for that things we can't operate all the features, right? Then for that we need to do like we need to extract the meaningful as well as the useful features, right? For that either we can go by principal component analysis, like otherwise we can identify the rank widgets. So that will help us to say like what are the major features that will help us to identify for better classification, prediction, or analysis. So that for that we have widgets called rank, or even we have color widgets or feature statistics or save data. For example, you have some data and you have pre-processed it, then you have to save the data, right? Otherwise the pre-processed data will be lost. So for that we have a option called save data. So on the same way, if you are working on the transformers, like the pre-processing operations, what are the major operations that involved on the pre-processing? Like for that either select rows, select columns, transpose, which means transpose means shift the row to column or column to row, or even we have a data samplers. Our data samplers is highly used when we are working on evaluating the data sets. Like for the data sets, data sampler means how we can we are selecting the testing and training ratio, whether it is 80/30 or 70/30 or 80/20. So these are all operations we are performing frequently on machine learning, right? For that we have option called the data sampler. In the data sampler widgets we can do all those stuff, right? If you click this each and every operation, it will clearly show like how this data sampler will work. So these kind of things, like clear explanation, clear documentation, as I said, right? The data sets, how it is we are fixing, whether it is a 70/30 or 80/20. And also we are using operations called cross validation, right? That is also another operations that we are perform on machine learning, right? To identify the classification accuracy, how we will do? We can just run on data sets one time and we can't report, right? We used to run multiple times, and on an average we used to report the classification accuracy, or even for that matter there are several performance metrics like uh, AUC valueless area under curve, or F1 score, precision, recall, FMSs, and all those stuff. For that, we have some operation called cross validation. Cross validation means, for example, given a data set, if you are splitting into 10 folds, which means the data set is splitted into 10 subgroups, then the nine samples will be used for training and one sample will be used for testing, right? So same way we can do 10 times. If it is tenfold cross validation, we can do the same operation 10 times. In each 10 times we are using the sub we can change the subcomponent for testing, right? As I said, 9:1. If nine subtype, nine categories used for training, and remaining one will be used for testing. This is, let's say, if 1 to 10, if first 1 to 9 will be used for training, and the 10th subgroup will be used for testing for the first time. Then the second iteration, which means in the cross validation, there are 10 folds. In the second fold, instead of 10, there are 5 or 6 subgroup will be used for testing. Same way, we can do 10 times, 10 cross folds. Then we can get the average classification accuracy, then we can report, right? So those kind of things we can do by using this operation called data samplers. So for that we have a widget called data sampler widgets. So like this we have several widgets for each and every purpose. As I said, select rows, select columns, transpose are self-explanatory. And merge data, for example, if you have multiple data sets from two different data sets, you think you have to combine certain features, which means either rows or columns, and you need to generate a unique data set, or from the real uh, data table you have to fetch a few data, and you have to identify, you have to merge and construct a view or a table. For that we can go for either merge data or concatenation and select by data index. This is an again if you have a number of records, from the records by using the index we can select, and unique will use to remove the duplicates, and aggregate columns which is used to say like in the excel operations we used to aggregate and we used to say like some value, number of count value like number of records, so those kind of things, and group by pivot, apply column. This is an important feature called pre-process. Like in the pre-process operation, what are the things we used to do, right? We used to do like handle the missing values, right? This is the most uh, important task that we are doing in the pre-processing, right? how we are you how you are going to handle the missing values. Either we are going to use by average or most frequent method, or replace with random value, or remove the rows with missing values. As I aware, like in the machine learning you used to study all these things, how it is working for average and most frequent value, and replace with random value, or remove rows with missing values. These are all how we are imputing the missing values. This is the methods are used for imputing the missing values, or select the relevant feature. As I said, if it is more than 10 or 15 features, from that how we are extracting the relevant features. For that we have a number of existing methodologies like information gain. It is information gain ratio. So that is the one of the technique that we can apply over to data set to get the relevant features, right? So and also select the random feature. For that how we are identifying the random features, and discrete variables, how we are continuing the discrete values, whether that is again based on the most frequent or one feature per value, and non-binary features or categorical value. This is the removing of categorical value. For example, like what is mean by what is mean by labeled data and unlabeled data. Labeled data means the data sets which contains the output class labels, right? If it is either, for example, if it is a male female classification, that is, if it is a data set, then based on the features of a human we have to classify whether the given feature is a male or female, right? That is the output class labels, either be 0 or 1 or m or f, male and female. So those kind of things are called as uh, discrete values, right? If you want to use the same data set for, instead of uh, labeled output, we have to use for continuous output. If you want to convert those kind of things, you have to remove that output class labels, the column, right, in the data sets. For that we can either go for these are pre-processing operation, and we can use, right? So these are all the major operations that we are use relies on orange tool widgets for pre-processing, and again impute is again for missing values. Or as I said, this is the open tool. If you want to operate, if you don't want to use the existing feature, if you have any specific scenario, then you have to write code for that one. For example, in the pre-processing, you are proposing some new pre-processing technique other than or in addition to the existing technique, like select row, select columns, data samplers. After pre-processing you have some more layer, additional layer of pre-processing if you want to apply. For that you can write code snippet in the Python. You want to run it. For that you have this option called Python script. Use this widget. You can write again. You have to imagine like all these widgets. As I said, all these widgets are similar to Python functions. You just to equate all these widgets individually is called it's similar to the Python functions. What is functions? The functions either may take input, it will provide you output if it is two-way function. Otherwise few function might not take any input, but they will provide output. Example is generating random numbers. Random numbers won't get any input, but it will provide you the output, right? Or few function will take input but it won't provide any output. So like this, each and every widgets have it is similar to a function. If it is two-way functions, which it has to accept the input and it has to provide you the output. If it is one-way function, it has to accept only input. If it is an out-way function, it has to only provide you the output. So all these widgets are similar to the Python functions. You have to just imagine like this. So if you want to any functional, you have to add along with these widgets. Similarly, you can simply write the function for that particular feature and use this Python script. You can apply in that feature that input has to be mapped with uh, any one of the widgets output. So I will explain you in the tool while you are working so that you can understand better. And these are all group of widgets. If you see here, it is these are all widgets are grouped based on its categories, like whether it is operates on data or whether it is operates on transformation, which means data processing, or these are all the widgets which involving over visualization, which means the output, the graphs and everything. Like, so what are the various kind of graphs or metrics that involved in the machine learning, right? Either we can use by distributions or scatter plot or line plots, bar plots, even we have like Venn diagrams, heat maps, linear projections, right? These are all we know, right? These are all nano diagrams or tree viewers. So these are all the visualization widgets that is supported by Orange tool. And here is the important stuff like machine learning models. What are the various machine learning models that is supported by Orange tool as of now is like KNN, trees, random forest, SVM, gradient boost, logistic regression. Yes, the frequent and the most used machine learning model is logistic regression and linear regression and neural networks, right? And stacking, and these are all two widgets that is not the model. But if you worked on the machine learning different models, either the models has to be saved, right? Once you have created one model, that has to be stored for your purpose. For if you have trained one model, you no need to train again and again. So once you have trained, you can save that model. And again, by using the load model, which means I am working on one data sets, or I have trained by using my resource. My resource means my computer, my GPU, and everything. I have trained some deep learning model. I know, again, if you want to work on the same model, but you don't have any computational capacity, and those kind of scenarios, I can just save my model, which means the trained model. Once I have saved, I can just say share that saved model to you. You can just use that model by using the load model. Load model is a widget used to load the saved model, and you can just test over that model. You no need to again train. So this is the two widgets specifically applied for save and load models. And if we are working on machine learning models, how we can evaluate different models? For example, we have logistic regression, KNN, decision tree, right? There are n number of machine learning models. How we can say like which model works better for a particular data sets, right? For that, what we have to do? We have to evaluate. We have to test models. From the results, we could say among the applied models, the specific model is works better for these data sets, right? That is what our ultimate aim, right? So for that, the model supported, the widgets supported by RH tool are test and score and predictions, confusion matrix, ROC curves, and calibration plot. As you aware, all these terms I know, but I am just refreshing like what are the various widgets that are already available for you to use. Like, then there are subcategories supported by unsupervised machine learning models. You know, right? What is meant by supervised and what is meant by unsupervised. As I said, if the output labels are classified in the training data sets itself, then that is called supervised model. If a particular training data set does not have any output class labels, means that is unlabeled data. If a data set contains unlabeled, then that is called as unsupervised machine learning model. The basic for unsupervised model is like it don't know exactly what was the output. The best approach for unsupervised model is they will collect first data sample from the data set, and with the next data sample they used to compute the similarity, which means how close, how relevant the first data and the second data in the data set. If it is mostly closed, then those two data are considered as a similar one, and that might be grouped in a single cluster. For example, if it is a clustering algorithm, that might be clustered in a single group, or if it is have far difference, then that will be either considered as an outlier or it will be the member of another cluster. So right, this is the base for unsupervised learning, right? So how the distance will be computed between the two different widgets, two different data points. Like for that we have various kind of mathematical computations, right? You aware, I guess. Like in the widgets, we these are all the different metrics we might use: Euclidean distance, Manhattan distance, cosine similarity, Jacob's points, right? Pearson. These are all the various metrics based on the nature of the data sets. We are using various uh, distance metrics to compute the similarity between the points, right? So this distance widget, is used to identify the similarity between the data samples, and from the scores we used to either form clusters, right? So these are all specific uh, widgets that supports for unsupervised distance file, distance widgets, K-means clustering, hierarchical clusterings, distance map, correlations, again PCA, outliers, DB scans, MDS, neighbors. So you are like all these uh, widgets are highly related to unsupervised learning. So for example, now as of now, so far we have discussed about generic uh, items which are all involved on machine learning. So if you are working few domains, like if your data sets only contains text, then we can go for text mining related widgets. Or if you have data with contains time series, if you are working with time series data, then we can have like spectroscopy, so on so on. Like for example, if you are talking about text mining, the one of the thing is the famous one over text mining is sentimental analysis, right? For example, now we are past my our MP elections, right? In the election and all, they used to post like the predictions, like how they are posting the, like whether this party will win, this candidate will win, how they will win, how they are providing those results. They used to uh, uh, analyze the social media informations, right? Whether they used to conduct a few formal surveys, or they used to calculate overall. For example, they consider either Twitter or Facebook chats or tweets or posts. From that, they used to infer information like whether a particular person is for the particular party, or they are against for the particular party, or what could be their ideology, how they are going to vote. These are all the predictions they, from the social media data, they used to analyze, they used to operate and analyze and provide you, right? For example, I am a person, I am putting some post related to particular party, let's say. How they will identify my constituency, right? Whether which constituency I am attached to it, so that they will count my vote to the particular constituency, right? How they will do? For that, they have to analyze my profile, like my Twitter profile information, like whether geographical information, like from where I have posted information, or whether in my post I have any data similar to Tamil Nadu, or let us say for Tamil Nadu or any particular district or any particular candidate. So they used to identify my profiles. For example, if it is I'm using Twitter, they used to extract my users' tweets from this widget called Twitter, and they used to analyze their profile by using the Twitter profiler, and they used to assess their votes, and they used to say the number of users for this party or number of users are against for this party by using sentimental analysis. Sentimental analysis again going for the similarity between the post. Like for that, they used to construct similarity hashing or word cloud, and back of words is like it is from the social media tweets. They used to collect all the words. Back of words is similar to, like, for example, given a paragraph, how many number of, for example, the particular word is occurring more number of words, the weightage will be more for that particular word. For example, if I am using one party name 5 times, in the back of words, again to the particular party, the count will be given as 5. Why this back of words will be used is like, as you know, machine learning will work only on zeros and ones, right? Numeric numbers. How the text will be converted to numerics? So by using the back of words, each and every word will be assigned to the particular value, which means that score. So from the score only they used to classify. These are all the tweets related to the particular party. So like this, we have to convert the text to numerics. For that, they used to use back of words. So assign the weightage to the words, and the word cloud will be used for collect all the words. So these are all related to only text mining. For example, we have pre-process is generic one, whereas text pre-process which related to more operation related to text, and corpus is again is used corpus widget is used to handle the files, whereas import document is again used to, as we have seen SQL widgets or file widgets to import file. Similarly, import document is used to import the document to the orange tool. So it is like of input, as I said, the functions, right? So import document is a function which is used to get the information to the orange widgets, then we can operate. So same way, survival analysis. So these are all related to particular domain. So for example, if you are operating on bioinformatics related data set, for example, disease predictions based on particular child gene records, something, right? So if you are working any data related to bioinformatics, there are all different data sets widgets available for uh, bioinformatics related things. So again here, the database updates, or even we have bioinformatics data sets imports. So these are all widgets. And if your data sets contain image, or for example, if you are analyzing image based data sets, or even in deep learning, how we used to do, we used to apply the deep learning models for image to either for example, disease predictions. For example, brain tumor detection or breast cancer detection and all, we used to provide the MRI scan reports, right, in the image format. From the image, they used to analyze and they used to identify whether the given image is affected by the breast cancer or brain tumor or not, right? Or even bone cancer classification, whether the given image is a cancer affected one or it is a non-cancer affected one, and so on. So if we want to work with image based widgets, for that we have to use these widgets called image import, image viewer, image embedding. So this is the feature. Like again, for as I said, the machine learning will work on numerics. How the image input will be mapped to numeric, right? For that, there should be a function that should convert the assign numeric values for the image based on its characteristics. Simply, we can't assign the numerics for the images, right? Based on the characteristics, it should assign numerics. From the results, we can say the numbers can be used by the machine learning models to predict or classify and say whether the given image is a affected one or not. this is affected one or not. So those things are image grid. So image grid is used to collect or see the group of image in a single plane. So save image. So again, it is used to save a particular image. So if you are working some network related operations, like currently we are using IoT and there are cyber attacks, as your principal insisted. Cyber attack is a booming area where there are a lot of attacks happening, or since we are started operating over the data, right? So once the data are increasing simultaneously, the attacker trying to capture their user information or sensitive information. So in order to restrict that one, we need to scan like where the attack is happening, or whether there are any open ports or closed ports available for our network, so on so on, right? Something we are working related to networks. There are the widgets related provided under the networks category for operating these operations. And geographical related information, like during the COVID they have provided the information, like in India, Tamil Nadu has this much information, or in the rainfall classification, rainfall information, they used to provide the image like India map, and they used to provide like the rainfall ratio and everything. So if you are providing a reports anything related to geographical information, we can go for geographical widgets. And for educational, as I said, if you want to teach the students like how the k-means clustering works, for that we can have iterative k-means clustering. This will visualize like how the each and every points, that iterations, we used to say like iterations, we used to run the k-means algorithm until the clusters are converged, right? So those things, like we have to fix the random cluster centroids, then we can run the algorithms, right? So for those kind of things we have k-means clustering. So these are all widgets related to education, like random data, pie charts, polynomial classification, polynomial regressions, those graphs and all, the curves, right? Those kind of things we can use this. Like if you are having some data on Google Sheets, so we can directly connect with Orange tool and we can provide the demo. As I said, if any data we have time range related one, if anybody has worked on time related data, the models related to time series are ARI model or WAR model, right? So these are all the few graphs related to time series, like line chart, uh, uh, parallelogram. So similarity between the data can be computed by distance. So model evaluate, as I said, whether you want to know like whether Arima model or VAR model, which one is better. For that we have used for model evaluation things. And explain, which is the widget used to explain by, as you are aware, right? We are now moving like the explainable AI, right? From the artificial intelligence to explainable AI. So for those things related to explainable, that things supported by these widgets like explainable. So I have just introduced all these widgets. Now I can directly go to the demo and I can show you like how it is happening. Like as I said, the welcome clear documentation will be there. Even the video tutorials available, YouTube videos, you can just go there, or even examples is available. Like for example, if you don't know how the hierarchical clustering is working, or how the class validation is working, the first time if you are learning, you can just go for example, in this case, I am opening hierarchical clustering. You don't know how the hierarchical clustering has to operate like. So if you see here, this is the this white plane previously. So this one is called as this white screen is called as canvas. So in this canvas we have to, these are all the widgets, as I already explained you, there are categorical widgets for each and everything. So either we can drag and drop these widgets like to the canvas, like from, if I drag, click and drag, this way I can do. Otherwise I can right click over the canvas, I can able to search these widgets. So this way also we can do. Otherwise, as I said, right, these all widgets are similar to the Python functions, where you see there are shaded lines on the right side of these widgets, which means these widgets will provide only the output, which means it will provide output. So in this, if you drag a line over here and you leave it, Here also it will provide you the options like from the file what are the various widgets that can be taken the input. So these are all like, which means the functions, the Python function file might provide some output, right? That output can be used as an input for the functions called outlier distributions, so and so on. So this is the difference. For example, if you have like uh, okay, I can now go for that example. Help example workflows, hierarchical clustering. I will go for hierarchical clustering. So this is the example, okay, hierarchical clustering. Here if you see distance widgets, so if you right click and select the distance widget, in the distance widget you see both sides shaded lines, which means the distance widget will take input as well as provide you the output. So these are all self-explanatory. So if you see here, uh, this is the file input. If you open, if you double click it, it will select you the, it will provide you the options like whether you are going to select from the dataset, or you have any Google Sheets or anywhere URL. If you have any datasets URL, you can provide here and it will get the information. For example, as of now in this example they have selected one dataset, so I am going to select some. Okay, as of now they have selected brown selected dataset. Okay, if you see this is the consolidation results, like in this dataset it has 186 instances, 79 features, which means out of 186 instance there are 79 features, which means 79 columns are there in the datasets, which is used for classification, which is has categorical values are 3, which means as I said the male female classification. Similarly, in this dataset there are 3 different class labels can be used. So these are all the information. So if you want to know the data in the data set, we can connect to the data table. It will just provide you the logical view, like how the data sets, our tables will look alike. Like same way. Here also it is reporting 180 instance and 79. If you see here, it is saying as 1.5 percentage missing values are there. These question marks reports missing values. How we can operate the missing values? We can go for impute option. You know, right? uh, we can go for impute. So in this impute, we can either go for whether don't impute or average or missing random values, or we can provide some provide some random values, or we can average and most frequent set. If you are applying this one, okay, if you are applied this one, and we can view it in the, so here data to data. So all the data is now imputed. Now, if you see here, all the missing values are imputed by using the most frequent one. Here also 186 instance, but no missing values. You can able to see, right, the difference. Like here 1.5 percentage missing values, whereas once it is imputed, it is has zeros missing values. So these ways we can operate the machine learning pre-processing stuff we can do. So like, so as I said, now we can come to hierarchical clustering. How the hierarchical clustering will operate? It will identify the distance between the points to another point. As I already explained you, how we can compute the distance between the data points. Either we can go for Euclidean distance, Manhattan distance, cosine distance based on the data sets, as you are aware. So once the distance is computed, if you see distance, uh, what we can say, distance map, it will show you like where the uh, high highly cohesive data is there, how the data which are close to this line is called as cohesive line, closely points, whereas the distance between the points and the line denotes like these are all missing, which means there are uh, it belongs to some other cluster or outliers, we can say. For example, if it is clustering view, you can just imagine. So this will be as one cluster, and this could be of another cluster, this could be of another cluster, and this could be of another cluster. You can just imagine, right? We are not doing anything. We can just connect it with different widgets and we can able to get it. So if you see here, the same thing. How many hierarchy clustering will be formed? It is showed here. Here also, so the same way, this entire thing is called as workflow. How we are connected and how we are operating, that is called as uh, uh, that option is called as workflow. The entire program that was connected is called as workflow. So now I will explain you like how the image analytics will works and how the text mining works. Okay, it, before that we can go for some. Okay, this is the model used for classification trees, right? You know, like decision trees, how we can connect the decision tree and how we can say, given the data set, we have to identify how we have to compute like various points. Again, here also we used to find the similarity between the points, and we can construct the decision tree. From the decision tree, what we can say, the inference from the decision tree is like which is the most uh, meaningful feature in the given data sets, like which feature we can take, then the given data set will be clearly separated. That is the purpose for decision classification trees, right? So for example, this is the data set. This one is called as data set iris data set. In the iris data set, we have 150 features out of 150 instance of 4 features, and there are no missing values. This contains 3 distinct classes. Okay, so if you see the distinct classes, it will say the metadata like what are the distinct classes. The output might be of iris setosa, iris versicolor, or iris virginica. These are all just like a male, female, and transgenders classification. So from the flower, we have features, 4 features: sepal length, sepal width, petal length, and petal width. Based on the 4 features, we are categorizing the flowers either iris setosa, versicolor, or virginica. So this is the data set. So from the data set, we don't know which feature is most meaningful feature. For that, we can connect with the decision classification tree. From the classification tree, we could see like if you are separate by using the iris setosa, then the data set is clearly separated, which means iris setosa is clearly separated, iris versicolor and iris virginica. So these are all, there are some misclassification between iris virginica and iris versicolor. Okay, if you want to visualize that one, you can able to use the scatter plot. Scatter plot is the one. mm, so even from the shaded arrow points, if you double click it, it will say like whether all the data has to be moved from one widget to another widget, or the selected points from the one panel to another plan. Okay, for example, if you cut this one, which means the connection between the 2 widgets will be clear. For example, if you visualize this data in the scatter plot, this is what the view of scatter plot. So as we know, like there is an option called informative projections. If you click informative projections, it will say as we are like there are different features, right? So if it will say like if you are using these 2 widgets, the scatter plot will be of the points has been cleared separately. Like if you see like the blue line Iris setosa is separately classified, for example, so the color region. So if you see, there are so green just. So these are all different options. So these are all we can easily do the stuff, right? So if you are separated by using these different thing, how the classification is will place like. So these are all the informative projections. You just imagine we are not operating anything. We are not doing any mathematical operations. Nothing we have done. We have just connected these plots, and we are what we can say. We have achieved whatever we want. So now I will just go for one image classification example and one text classification example. Then we can close as we are exceeding times. So I will go for image classifications. Okay. So if you see, this is the workflow connected for image classification. As I shown you, like how the image classifications will look like. For example, I am going to load or data. This workflow is once it is saved, we can just change the data set from this widget. Immediately the results will be populated all over. For example, I have used data set. If you see here, once I have changed the data set, it will immediately the results are populated to all the other field. For example, you don't know what I have imported. If you see the image viewer, it will show you what are the things I have imported. I will show you the data set now. Like in the data set, I am having image for domestic animals. There is a data set for domestic animal which contains the domestic animals. From the this data set, either we can go for animal data set, or for the paint data set, I'm having monet or manet images, this diagrams like paintings. So I'm having this data sets. If you clearly see this image data set, I'm having two class labels. One is for manet, another one is monet. This is called as labeled input, which means supervised learning. This is domestic animal data set is unsupervised learning, which means no class labels I have applied, right? For example, I have loaded this image classification and we have seen the images, right? Even we have image grid. There is an option for image grid. Here also we can able to see like how we can map that data. So these are all group of images. How we can see like everything we can select these features. Okay. So as of now, I have shown you what are the images I have imported. As I said, the image embedding is option which convert image to numeric values. You just want to see like how you have to, for example, initially without embed option, I am directly connecting the data table. In this only we have information like what are the category I have given, what is the name of the image, and what is the location of the image, size, width and height. These are all the information that we already aware, right? In this if you see here, here itself we can show the name, size, width, everything, right? So there is nothing with this information, we can't do anything, right? So once this embed is happened, if you connect with this data set, if you see here, it is now it contains 27 instances of 1000 features, which means given the information, deep learning model is fetched these 1000 features from the image. So these numeric values will be used for image classifications. Now, then we are connecting with the distance widgets to compute the similarity between the data points, and that can be either connected to hierarchical clustering. If you see the results of this hierarchical clustering, if you note one thing, if I change here, immediately the results of clusters will be changed in the subsequent tabs, which means one data of results immediately populated to another window of the orange widgets. This is also one of the iterative, this is called as iterative programming. So, so this way these images were classified, right? This way we can do the image classification. Now you want to, instead of operating as this painting data set, you want to work with animal data set. How we can do? Whether you have to create this similar workflow again, no need. Simply we can go and change the data set. Instead of mono data set, now you can select domestic animal data set. Now if you load, reload, now you see the results immediately populated. If you see hierarchical clustering, there are two clusters. You want to see the results? See, this cluster C1 contains the animals which has two legs. If you see this one, the animals which has four legs. So the classification is quite high, right? It is well classified. So this way we can operate on uh, what we can say. We can operate over image classification. So next we can just see one example like how we can model can be evaluated, right? That we can see. Or text mining we can see. Next one, text or document or something. For example, text mining. Sorry. So if you see the text mining, so here I can connect with corpus. From the corpus pre-processing text, I can connect with word cloud. It is, if you see the red lines, which means the results are populated. So here I have some data to be. If you see, this is the word club, which means from the given documents, the words are weighted with their number of occurrence. If you see here, little is uh, uh, little is the word appear 275 times of the given documents. So that is displayed here uh, with big size, whereas the word which contains lesser occurrence like morning is uh, printed with smaller in size. So similarly, number of word count, the word cloud will be formed. As I said, back of words is the one which is mapped with number of words to the numeric values, right? So this is the test and score widgets, which is used to evaluate the data sets for, sorry, machine learning models. As I said, here if you see whether the cross fault validation you are operating a test and score methods or leave one out, which methodology you are operating, and this is the results. Like what is the F1 score, what is the classification accuracy, what is the precision, recall, ROC curve percentage. So test and widget is used to evaluate the model. So not only logistic regression, we can test with random forest for this one, or KNN, or so whatever models, if you want to compare, you can just connect with these models, and the test and score widgets will operate over those results, and it will provide you the corresponding output. See, like if you see the operation, it is working on the various operations. You see here, you have like random forest or the complex one. In fewer case, it is working. It might provide the better classification accuracy, whereas fewer data sets, the logistic regression itself will provide you the better accuracy. So, in how you can evaluate these different models, without a matter of codes, we can just connect with this workflow, and we can just use this test and score and so on everything, and we can able to visualize it. You can just see now the results are almost completed. It is 89% now. See, now the results are printed. Like the results for based on the classification accuracy, still logistic regression works better for these given data sets. So similarly, we can work with different data sets. There are confusion matrix, like how the confusion matrix will work. So based on the confusion matrix, we can say how the missing values are, what are the missing values, number of missing values, and if you want to see like how these missing values or which document is missing classified. If you want to see, you can connect with corpus viewer and you can see. So if the same workflow can be applied instead of corpus, if you connect with file or image, the entire workflow can be used for image based model evaluation or text based model evaluation. So hope we have exceeded time. With this, I can conclude. If you have any question, you can ask me.
Thank you very much for this wonderful session, sir. Over to the audience. Any queries, you can please ask him, or you can please post your questions on the chat box.
Yes, if you want to post, you can post. I will answer.
Well, sir, I have a small question. Like we have various tools related for this data mining and data visualization. Say,
Yes,
for
ma'am.
example, we have Tableau and NIME. So, of
Yes.
course, NIME is an open source one, but Tableau is not an open source one. So, in what way Orange is different from these tools?
Yes, ma'am. You have you seen like any tool related like drag and drop and which is evaluating the machine learning model or deep learning so far?
Oh, yes, sir.
No,
Drag.
right? We have to do some coding, right, for other tools,
Yes, yes, sir. Yes, sir.
but it is absolutely free and we can uh,
Yes, sir.
easily
Of course.
operate. Yeah, right. That is the
Uh,
biggest advantage I could see.
okay, okay. This one is drag and drop.
Yes.
Some features, even in Tableau, we have some drag and drop features, sir.
Okay,
Uh,
ma'am.
in some concepts. So that way I'm asking you. Of course, but Tableau is not open source. They have some limited features in open source. It's a nice experience. So any queries, audience? Okay, so let me have my up. The session on Orange tool is really an eye opener for all of us. The hands-on demo on Orange given by you gave us a brief insight about the various features of Orange. The session also highlighted the role of the Orange tool that is widely used in data mining and machine learning applications. This would really motivate all of us to use Orange in our research as well as in academics. Thank you very much for this valuable, informative, and noteworthy session, sir. Thank you very much.
Thank you, ma'am.
Thank you, sir. Thank you very much,